What's up, guys? Now let's talk about API design. What is API design? Why is it important? Let's get into it. So, what is API design? API design is the carefully planning, preparing, and developing program interfaces, right? So we can expose data and functionality to our customers, right? An API design always has good answers to the following questions. First of all, why is it being developed? What would the outcome concerning the impact and outcome of the project? So, what do we expect to happen by making an API? How will the API be designed to meet our requirements? What will the structure of our resources be? Right? How will we document our resources? So, if you don't have answers to all these questions, then likely you're building an API for no reason. Like, there needs to be solid business reasons for you building an API, right? So, API design involves using remote services to solve problems so that customers' functional and non functional goals are met, and they must always be aligned with business goals. So, for example, say we have a new product coming out, or say we're a retail company and we're selling shoes, right? And we want to build a website that, customers can access and order shoes online, right? If there was no product, if there was no service to be given to customers, then why are we making an API to begin with, right? So, why does API design matter? People would switch to a different API with the exact same functionality if the design is poor and it works poorly. So with our shoe example, say, we have an API, but we designed it really poorly. It's super slow. It's, really bad, right? Customers would likely switch to a different business to buy their shoes with a better working website, right? So requirement analysis should always be performed before the development of the interface during the design phase. And this is done by getting internal or customer feedback. So let's take a look at our API design lifecycle. So here we have our lifecycle, right? First we design it, then we'll try to prototype it and use it, analyze the behavior, update it, right? So we kind of go through this pattern. So this is when we're designing it. But if we're going to go ahead and code it, then we have to design it, develop it, deploy it, publish it, and then go through this whole cycle, right? So usually it's faster, obviously, to just design, prototype, and just see how things are looking before totally committing to programming it, right? So let's talk about design first versus coding first. So design first focuses on creating the API's contract or specifications before writing any code, right? And code first is always good for quick development of the product, say an API for little internal use, right? Say it's like a small little application that does like a few scripts internally, then maybe coding first is a good idea for that. And maybe you don't need any documentation for it, right? But at the same time, it wouldn't make sense to build a house without an architect making plans detailing that house, right? I mean, obviously you can build a house like in a few weeks without even planning it out, right? But, does that house meet all the requirements you're looking for? Will it last for years and years? Will it last a storm? We don't know that, right? So, API design considerations. So, this is what we should consider when designing an API. So, first we have to think about who are our users. We need to think about who our users are, their relationship with the business, external partners, customers. We need to define the level of access that they need, like authentication and architectural style. And we also need to identify the problem. Like, what problems are we trying to solve? What business problems are we trying to solve? what critical needs and value are we adding, right? And we also need to think about the metrics that will improve after using the developed API. So, like revenue or the speed of completion of a task, the cost, so on, right? And we also need to think about the response type. So, so say we need to identify the responses to different API calls so developers can understand the type and reason of the responses received by the server, right? And exception and error handling must be implemented with well-defined endpoints, right? And we also need to think about our use case, right? And we need to make sure our testability factor is checked and developers can understand the effectiveness of the designed API. We need to think about scalability. Can we handle increased volume of users as it grows? And we also need to make sure that we're documenting it so our developers know what they're looking at when they start looking at this API. So let's talk about the different API requirements. We have functional and non-functional requirements. So functional requirements are like our defined end function. So say we have a social media that should support posting of photos or posting, comments on photos. Since that was a well-defined feature, that should be in our API, right? And then there are also non-functional requirements, things that aren't really said, or that should be added, right? So the performance and quality of our API. So it should be low latency, it should be scalable, available, reliable, and consistent, right? So what are the characteristics of good API design, right? So good API design has concurrency, right? The amount of API calls that can be active simultaneously in a specific period. Dynamic rate limiting, so a strategy to limit access to an API within a specific time frame so we can avoid overwhelming our API. Obviously security, so not everyone can access the API. Error warnings and handlings, so errors are inevitably going to show up, so do we handle those errors gracefully? Do we handle them well? Our architectural style, so there's different architectural styles for different use cases. So are we choosing the right architectural style? It should be minimal but comprehensive. So we're not coding too much, using too many resources, but it's comprehensive enough of a solution, right? Stateless or state bearing. Do users actually adopt the API? Is it fault tolerant? Like, does it handle faults or handle, crashes well? And also, does it perform well, right? So that's the end of this section. Hopefully you learned something, and thanks for watching.